Hello everyone, welcome back to our channel. So Shomu sir, geometry questions today also?
Yeah, we'll be continuing geometry for a while now, Harshal. Another interesting problem, pretty straightforward if you understand the picture properly. Now this type of question, I would say a lot of people would face problem. One, obviously the comprehension is important. And two, if they do not understand how to simplify the problem. So let me take this particular question as a good example for these types. Let's get into the question so that we better understand what I'm trying to say. So let's comprehend it first properly. So we have ABC, a right-angled triangle. This triangle has been written a couple of times. It's a right-angled isosceles triangle. So let me just scratch this out for the time being. But anyhow, ABC is a right-angled isosceles triangle with hypotenuse BC. Let BQC be a semicircle away from A. Now, what does that mean as away from A? Diameter is BC, that is known to us. But away from A means the curvature of the semicircle that will be there would be away from A. So for example, if I start by drawing the triangle, just for the reference of comprehension, you should not ideally draw in geometry questions, the figure in between your comprehension. That is always something I suggest. But this is just for your understanding, whoever is watching this video. So you have this ABC right angle triangle. A has to be the 90 degree because B is the hypotenuse. Now what it means as, if you have BC as the diameter of a semicircle, so you can have it two ways, right? You can either do it like this. The curve can go, or the arc of the semicircle can be on this side, or it could be on this side, right? So there are two possibilities. And now what it means by away from A is it is not this possibility. It is not passing through A. It is the other way around. So it goes something like this, right? A very bad one, but just to explain to you. So that is the semicircle that we're concerned about. Let BPC be an arc of a circle. Now BPC, again, P is some point on that arc. So BPC be an arc of a circle centered at A. So the circle has a center at A and lying between BC and BQC. So which is lying between BC and BQC? BPC as an arc which is centered at A and which is lying between BC. So this arc is lying between BC and BQC, right? So this arc should go something like this. So we have, if AB has length 6 centimeters, so the AB length is given, then the area of the region enclosed between BPC and BQC. So this has to be constructed fairly properly. So let us do that first. So we have a semicircle. Ignore my curvature. My curvatures are never good. So for rough work point of view, it's fine, I guess. So this is a semicircle. And then you have an arc BPC, which is lying between this BQC and BC rather. So again, this point P and Q is not relevant. This is just a reference here. So we are concerned about this particular area, right? That's something that is lying between the BPC and the BQC. The one that is between these two, right? Now, couple of things out here. AB is 6 centimeter. And since ABC is a isosceles right angle triangle, so this also has to be 6 centimeter, right? So this is all we have. And we are concerned about this thing, right? Now the face of it, this looks very difficult, but try to handle it smartly. What I mean smartly is, first of all, think about which regions, when I say regions, it could be combination of multiple regions or something, but which figures you can determine the area of, because the question is about area. So which figures you can easily determine the area of. So if you think in this way, it should be pretty obvious that obviously of the triangle ABC, we can determine very easily. We can determine the sector BPC, because this BPC, not only we know that it's a part of a circle, but the center is at A and this is 90 degrees. So this BPC is basically a quadrant of a circle, right? So the sector BPC we can easily determine area of, as well as the semicircle BQC, right? So the semicircle BQC we can determine very easily, right? So once you have figured this out, so this thing you can do mentally or written. If you have a habit of solving these kind of questions in this manner, then you can do this thing, whatever I'm doing now, mentally. But for now, let me just write few things. It will be easier for you to visualize. So what I'm going to do is I'm going to divide these this entire shape or whatever we have here into the three distinct regions that we have. So we have a region 1, a region 2, and a region 3, right? Now our requirement is this region 3. This is the requirement, isn't it? And whichever figure we can easily determine. So the three things that we determined initially, I mean, these three shapes area we can determine easily. Let us see what regions do they comprise of. So for example, this triangle ABC is simply this region 1, right? This is only region 1. Now the sector BPC, if you think about, this is a sector we are concerned about, right? So the sector BPC is a combination of 1 and 2. So this is a combination of 1 and 2. And the semicircle BQC is a combination of 2 and 3.
Correct.
So here, if you think about this, what is the requirement? The requirement is this 3, right? So focus first on the semicircle BQC. So if I think about semicircle BQC, apart from 3, we have this hanging 2 region out here, right? I mean, the region 2 out here. Now the sector BPC also has this region 2 along with it, isn't it? But then that has a region 1 in it. So how to simplify it? If you're good with basic equation thing, it should be pretty obvious that if I add these two and then subtract this one, my job is done, because added these two is 1 plus 2 plus 3 and subtracted 1 plus 2, I'll be getting 3, right? If you're not getting it, you might do it in 2 steps. So for example, you can think that if you subtract the third one minus the second one, so you'll have something like 3 minus 1. And then if you add back 1, you should have 3, right? So there are a couple of ways to understand this. So the simplest way would be something, as I mentioned earlier, if you add these two, the first one and the third one, if you add these two, and then if you subtract this, so what are you getting? So added these two is 1 plus 2 plus 3, and then subtracted the second one, you get 1 plus 2 subtracted, this whole thing subtracted. So you're left with 3, right? So basically what we are doing is we are adding the semicircle BQC with the triangle ABC and then subtracting the sector BPC. So if we do this, we get an answer, isn't it? So now just let us plug in the data and get the answer. So first of all, semicircle BQC. So BQC has the diameter as BC, if you remember. Now the diameter BC, by the way, BC would be what? 6 root 2, because you have a right angle triangle, couple of sides 6, the legs, so
Right.
hypotenuse 6 root 2. But this is a diameter, so the radius would be 3 root 2, right? So semicircle area would be pi into r square, r being 3 root 2, half of it, that would be the semicircle, plus the area of the triangle ABC, that would be simply half into 6 into 6, and subtracting the sector BPC. Now the sector BPC is basically a 90-degree sector, so it would be 1/4 the area of the circle. Now in this case, by the way, don't make a mistake, so this BPC center is A and this is the circumference of this sector, right? So this AB is the radius, isn't it? Or AC, whichever you want to pick up. So that is the radius of this particular sector, right? So the radius is, let me just do it in that way, pi into radius square. Now the radius is 6, so pi into 6 square and 1/4 of that, right? Now, if you quickly check this, I mean, just check this part. I mean, this is root 2 square is 2 and this is 2. So this, after taking out of the square, I mean, this cancels out. So you have 3 square left and 9. So that is 9 pi. And this is 36/4, which is also 9 pi, right? So this entire thing will cancel out. And what you're left off is this particular thing. And that would be the answer. So half into 6 into 6. So that is 80.
Nice. So I guess the important part was the comprehension part and understanding, how to pull off this question.
Right. That is true. And also the regional understanding. I mean, you have to understand the regions. If you don't understand how to relate the regions, you might get confused. I mean, what to add, what to subtract, you can get a bit confusing. So, I mean, to some people who have done questions like these, I mean, you don't have to explicitly do it. I mean, in this way, I mean, 1 plus 2, 1 plus 3. You should be able to observe that since you are focusing on this particular region, that is primarily under the semicircle, right? So from the semicircle, if I add the triangle, I get this whole thing, right? Because the semicircle and the triangle are completely disjoint, isn't it? So if I add the semicircle to the triangle, I'll get this entire region. From there, if I subtract the sector, that's it. So visually, it is actually faster to figure this out instead of doing this 1, 1 plus 2, and 2 plus 3. But I wanted to explicitly mention this once so that even those who don't have a habit of visualizing these kind of things can solve these kind of problems.
Right, right.
Yeah, so that's it from my end.
Thank you, sir. Thank you so much for this wonderful question. Thanks everyone for joining in. Have a nice day.
If you haven't yet checked the full playlist containing this video, then check the description for the direct link. Also, if you enjoyed this video and want to stay updated with our daily questions, tutorials, and problem-solving sessions, make sure to hit that subscribe button and the bell icon to never miss an update. In addition to our daily questions, we also offer comprehensive preparation for CAT and other management entrance tests. If you're looking to excel in these exams, we highly recommend checking out these courses in our website. To get a taste of what our courses have to offer, we invite you to take a free demo. The demo will give you a glimpse into the quality and effectiveness of our teaching methods, study materials, and practice resources. You can find the relevant links in the description of this video. Have a nice and successful preparation ahead. See you in the next one.